What is a contour plot? When I was looking at this beautiful hill behind me, I thought that that was a perfect example to illustrate what a contour plot is. A contour plot is a two-dimensional drawing where the lines on the plot represent constant elevation. So if we look at this hill over here, each kind of ridge is at constant elevation. As you're walking along one of those ridges, like let's maybe look at where the people are, that's kind of like one of the main ridges. They're not going up or down, they're walking along constant elevation. And the same thing for all the other ridge lines. So if we look at a contour plot of that, that's this thing, where this heavy line is the walk line where people are walking. So as they're walking along this, they're not changing elevation. And then I'm drawing some of the ridges for each constant elevation. And that there's a couple of interesting properties about that. When the contour lines are far apart, that means it's a gradual increase. And when the contours are really close, that means it's really steep. So let's look over there near the top of the mountain. See how it's very steep there, and the way we draw that is with the contours very close to each other. The other cool thing about a contour plot is which direction is the steepest descent. If I wanted to go straight to the top of the hill, which way should I go? So the contour, walking along the contour, you're not changing elevation at all, but if you walk perpendicular to the contour, then you're walking straight up. So this has a cool property for optimization. So let me draw what that would look like here. If I wanted to go straight up from here, I would go perpendicular to the contour. That would be in that direction. And then perpendicular to the contour. Perpendicular to the contour. Keep following that, and I end up at this. This is an interesting point. This is a maximum. Let's look at the top of that hill. The very, very top of the hill just has a point as a contour. So I showed like it's kind of intuitive. You would just walk straight up that hill. But it also works. Suppose we started over here, like where we're gonna need to, and we wanted to get to the top. We're gonna have to kind of walk up that and then walk up that to get to the top. And so let me show you what that would look like in terms of going perpendicular to these contours. So we're starting over there. We're starting somewhere on this hill, and we're gonna kind of have to get to the top of this hill and then get to the top there. So what that would look like is we start here, go like this, and this is going to take us kind of to the top of that ridge, and then perpendicular to the contour comes like this. So what that path would look like is walking kind of straight up this hill, and then perpendicular to the contour we walk along that ridge. So this is cool for optimization problems, but it's a way to find a local maxima, but it doesn't necessarily find a global maxima. In this case, there's only one hilltop, so it would find the global maxima. So let's look at the ocean too. Let's look this way. So it's a cool and beautiful application of explaining what is a contour. And in this case, the function is elevation, but it doesn't have to be elevation. It could be some kind of thing, some function you're optimizing. And if you walk perpendicular to the contour, you're walking in the direction of steepest descent. And we're here in Cinque Terre. This is Manarola. And now you know what a contour plot is. A 3D contour plot. And this is a really cool example of a 3D contour plot. So if we zoom in on one of these lobes here, we'll see like a cyan contour and then a blue contour. You could imagine, like for example, maybe you could think of it as a flame inside the center of one of those spheres. And this could be like the temperature contour, like at a certain distance away, it's one temperature, and then a little farther away, it's a little cooler. So this is a nice example of a 3D contour plot. And it also has the same property that if you travel perpendicular to a contour, you're going towards the maximum. So the contour is a surface, and perpendicular to it is normal to the surface, and walking normal to a contour takes you to the maximum. So we saw the same property in 2D or 3D, that walking perpendicular to the contour takes you to the maximum. And this is a beautiful glass sculpture in Venice. So now we know about 2D and 3D contour plots.
Yeah. Let me sit down and give it to me.